And today's talk is going to be from the perfSONAR group, and it's going to be talking a little bit about TWAMP, which is the two-way active measurement protocol, a little bit different than OWAMP, which people may be familiar with. And it's going to be led by Antoine and Szymon. So I will turn it over to Szymon, who I think is going to start us off.
Thank you very much. So good afternoon, everybody. My name is Szymon Trocha. I work for PSNC in Poland and for JUNIPER project. And today I'm here with Antoine Delvaux, also working for PSNC in JUNIPER. And on behalf of the perfSONAR project, we want to give you an overview of the latest additions to perfSONAR, which are related to TWAMP. So we will introduce you to the protocol itself and how it fits into the perfSONAR architecture and how it's implemented in perfSONAR. And this will be, in fact, follow with some examples of the application scenarios, so how we can use TWAMP in real life. And then Antoine will also present some real examples of the tool usage of TWAMP with the CLI commands. And you will also see how it's integrated with other graphical tools in perfSONAR, namely the pSconfig for mesh configuration and graphical tools. And we'll sum up with showing you some future efforts in perfSONAR related to this implementation. So let's start with some basics of TWAMP. So if we look today for measurements protocols, probably the most common one, the most common tool which is used to measure network performance is JSPing, which is measuring with ICMP and is already supported by most of the systems in the world. On the other hand, we have this well-known OWAMP protocol, which is used for one-way measurements. And you probably use both in your engineering work. On the other hand, users may see some shortcomings of both ping and OWAMP, because, for instance, ICMP is often rejected on routers, on network devices. On the other hand, OWAMP, as a one-way delay measurement protocol, requires precise time synchronization of both the endpoints. So users sometimes are looking for different tool, and here TWAMP comes in. So TWAMP stands for two-way active measurement protocol, and it was defined in RFC 5357 by IETF. In fact, TWAMP is based on OWAMP, a well-known one-way delay measurement protocol, but it adds two-way measurements capabilities to it, so that you can do these kind of performance measurements between the two TWAMP-enabled endpoints. Unlike OWAMP, those two-way metrics typically do not, in fact, require the precise host clock synchronization, which is helpful in deployment because users do not have invest in precise timing synchronization. In the context of using this protocol for measuring performance, TWAMP is also often implemented by some major network device vendors like JUNIPER or Cisco, where it's used for service level agreement verification, which is built into the network devices and then used by some tools and applications provided by the vendors. But as you could see in the next part of our session, this can also be used with perfSONAR. And finally, since TWAMP is a layer 3 protocol, layer 3, so IP routing network, is required between the agent and the target device in order to be able to run TWAMP measurements. So if we look at key elements of TWAMP, which are depicted in the upper part of this picture, there are two key components, in fact. So these are the endpoints, the so-called controller and the responder, and there are protocols. Each of them have a specific role in the measurement process. The endpoints and the controller and responder, in fact, consist also of smaller two logical pieces called, on the controller side, control client and session center, and on the responder side, server and session reflector. And we have these two protocols called TWAMP control and TWAMP test. So as you can see, the control and the tests may be separated. So the controller node, if we look closer into it, is in fact the master of the measurement process because it controls all the aspects of the test. So this is what control client does. It also has this element of session sender, which is responsible for generating the test traffic, and it's also processing the returned traffic from the responder. The other endpoint is responder, and responder processes and returns the test traffic, which is receiving from the sender node. But besides just looping back the traffic to controller, it also does some additional work. Mainly, it inserts the timestamps, the sequence numbers in the response packets. The server, which is talking with the control client with the use of TWAMP control protocol, listens for those control messages, and it manages the test sessions with all the TWAMP clients. It takes care of things like the session ports, and sometimes it can also respond with additional characteristics for the session, like, for instance, the authentication level. So these are the main key components, and as you see, they could be physically separated, but there are those four logical entities and the two types of protocols. So if some of you know how OWAMP protocol looks like, this may sound familiar for you. So let's also have a short look how the test process looks like, how it's established and done. So at the start of the process, the control session is established with the use of the TWAMP control protocol, where the control client on the controller side exchanges the control packets with the server, which is residing in the responder. And then the server acknowledges the setting up of the control session and sends also parameters like UDP port to be used with the test between the controller and the responder. When this process is set up, so the test is already negotiated, the test itself can start with the use of the TWAMP test protocol. So the session sender in the controller, in the sender side, initiates a test by generating UDP test traffic towards the known UDP port, which was exchanged before. And the TWAMP test protocol is used for this exchange. So the test packets are sent towards the session reflector. And in fact, if we said that OWAMP was the basis for creating TWAMP, these are the same packet format as used in OWAMP in the testing. So upon arrival of the test packet into the session reflector, it sets a timestamp, in its own timestamp into the packet. It's also extracting the information from the packet, from which it compiles a new one and adds another timestamp. Why two timestamps at the beginning of this process and at the end? Because we will have the information how long it took to process the packet by the session reflector in the responder. And the session reflector just reflects the packets with this basic manipulation, but it doesn't collect any packet information, any measurement data. Finally, when the packets are sent back to the session sender, it receives them and it communicates the results. Finally, it is the control client to close the session and the whole process stops. So this is how this process looks like. So you see it's similar to OWAMP with some modification. There is also a light version of TWAMP, a simplified architecture of the above, which implements a so-called light test point, where the two hosts are a bit different from this picture because they do not use the control protocol at all. And the controller plays the role of three logical entities: the control client, the session sender, and the server. So the responder just contains the session reflector. What kind of measurements can we expect from TWAMP? They are very similar to OWAMP, but of course they are two-way measurements. So this is round trip time, packet lost, packets reordered, duplicated number of packets, delay variation. It's also a number of hops, TTL, which can be, for instance, used to discover path asymmetry. And the processing time, this is the thing I mentioned on the reflector side, where the two types of timestamps are put into the packets. And although TWAMP is named a two-way measurement protocol, it's still possible to get one-way metrics. You can still have those endpoints synchronized, and you can then get the one-way delay values, and you get for forward direction and backward direction. That's how it's calculated by TWAMP. You will see it precisely when the CLI demo is done, what are the results presented by TWAMP. Based on the basic values, there are also some related metrics presented when you run TWAMP comments, which are calculated from the list above. So let's have a look how this is placed in the perfSONAR architecture. So as you are familiar, perfSONAR is a collection of different types of software for performing, but also sharing the network measurements. And it also consists of multiple tools which are brought together. And this architecture is depicted in the picture you currently see on your screens. So from the top, let's say there are those all visualization tools. Some of them you will also see in a presentation. There is a database to archive our data. pSconfig is a piece of software used for configuring meshes. That's a new one. And there is this scheduling layer, which we call pScheduler, which is used to manage all the tests for perfSONAR. And at the bottom of that, there are many utilities which are responsible for carrying out the actual network measurements, so the tools, in fact. So you can recognize iPerf, ping, traceroute, different flavors of traceroute, the OWAMP implementation, and there is also TWAMP implementation and the TW ping tool which is used in perfSONAR. So this is, let's say, the foundation layer of perfSONAR, and also the selection of tools you can use when you run your measurement. And it's, of course, this green box, so lookup service, which is used for service discovery. So TWAMP is implemented as one of the tools, and it's a latest addition to our set of tools. The client is itself named TWPing, so that we are able to run tests against all the other types of TWAMP servers. The important thing is that in perfSONAR, you usually do not invoke these tools directly, although you can, but instead you use a kind of wrapper, which is the pScheduler, from the scheduling layer to execute the tool. And the latest development of pScheduler allows it to be very flexible. You can add many plugins into it. And one of the plugins, which is called pScheduler tool TWPing, is in fact the one for running the tests, which we call of type latency or RTT round trip time. And yeah, with pScheduler, in fact, it's not only, you can run not only a single test, what you can do with just the tool, but you can also set up periodic measurements via the pScheduler command line interface with pSconfig, which is the more advanced mesh configuration tool, with the web admin for pSconfig, which is the graphical user interface for that, or through the pSconfig templates, where you can specify directly what type of tool you can use. So you will see some of that in the next part of our presentation. So let's have a look like this is implemented in perfSONAR. So what choice you have? This is included in selected bundles. The most known one is the toolkit, which is also available as an ISO DVD. So if you install the full toolkit, both from the DVD or from the bundle, you will get the full set of tools and services, and TWAMP is also there. In addition to that, you can also pick some smaller pieces of software from perfSONAR for your own installation, which is different from the full one, where the TWAMP capability is also there. So for instance, the perfSONAR test point bundle, where TWPing is also integrated, but there's also pScheduler, which allows you to automatically run the tests. You can join the mesh, you can participate in a centrally configured type of meshes. And finally, if you just want to use just the command line clients to run on-demand measurements, you can install the perfSONAR tools bundle. This is, let's say, a choice which is best for hosts which are not dedicated measurement hosts, but you just want to test, to use the command line utilities for some kind of troubleshooting. So this is what is available currently. The latest version of perfSONAR is 4.1.2. And you can already use it there. In terms of binaries which are available in the implementation, this is based on OWAMP binaries, because, as I said, the architecture of the protocol is very similar, and this is in fact reflected in the implementation, because in fact, thanks to an external contribution to our perfSONAR project, we have a patch to OWAMP binaries, and TWAMP is implemented there. So it has the same code base, and it has the same version number. The latest one is 3.5.7, and soon we'll have a new one, 3.5.8. For the other binaries, if you see on the left hand side of the screen, the TWAMP-D is the server process, you remember from the architecture, and you will also see this process in the main toolkit GUI, which is listed there, and you can check if it's running. And the TW-ping is this command line client, the tool which you can use to run on-demand measurements from the CLI without the usage of the scheduling lever. And what's worth mentioning here is that this TWAMP integration with perfSONAR is currently the only open source TWAMP implementation we know about. If somebody knows about the other TWAMP implementation, the open source one, we will be happy to hear, but that's what we currently know. So coming closer to the real presentations of how TWAMP can be used, we can look at possible application scenarios for it. So there are generally two of them depicted in this picture. So where you are doing tests with network device using perfSONAR host, or you are doing tests between two perfSONAR hosts. In the first scenario, where you have a perfSONAR host and a network device, the perfSONAR host is running a test towards the network device. It could be a Cisco router, a JUNIPER router. We'll use JUNIPER router in our examples. And it's worth mentioning here that although for the vendors of network devices, it's common that they implement both the session sender and the reflector on the same router. Some of them depends on the hardware, it depends on the operating system on the network device, may be capable of working only as a server. That means that you can only run a TWAMP test towards the network device, but you cannot initiate a test from the network device. So the network device is not able to act as a client. The other example is just using the two perfSONAR hosts and the test runs between them. This could be either the on-demand test with using the CLI tool. This can also be a more advanced scenario where perfSONAR host is part of the mesh and it's running the scheduled TWAMP measurements in a mesh. This grayed out box in the middle of this picture means that, in fact, there is also a possibility where the tests are initiated by a controller, by a perfSONAR host, which is submitting the latency measurement task to run from an external client to the other host. So from a client to the session sender. There is also a possibility like that. So that's a general introduction to TWAMP, and I think I will now hand over microphone and the screen to Antoine, who will take you to the journey about the CLI usage and the demonstration. Antoine, floor is yours.
Okay, thank you, Szymon. So I will continue with some examples of how you use TWAMP on your Linux machine and how what are the the actual measurements output that you can get. So let's first have a look at some example commands of running TWPing on the command line. So if you're familiar with OWPing, those commands should be fairly straightforward because it's really the same kind of interface and the same switches that are used with TWPing and OWPing. So in the first command here, we run TWPing and we ask it to send, so it's the TWAMP client, and we ask it to send 250 packets towards another host that is running the TWAMP server and TWAMP reflector process. And this will get you some information about the packets and the measurements that will happen. And if you want to see more output of that, you have the V switch, which gives you verbose and full packet details of the forward and backward measurements and the round-trip delay. As OWPing, you can also save your measurement session to a file and then analyze it further with OWStats, which is part of the package with TWPing, and that was already existing before, actually.
Antoine, we have a question.
Yeah.
Kate wants to know on the previous slide, if you want to go back one. On the previous slide, what does the only 10 packets mean?
Yeah, so it's a typo. It's only it's 250 packets. So I had made an example with 10 before, but
okay, thanks for the clarification.
Yeah, sorry, it's a typo. And I will show you as well the pScheduler integration, and this is how you would run pScheduler latency task with the TWPing command. So if you are familiar with pScheduler, this shouldn't come as this should be straightforward as well. So you ask pScheduler to perform a task using the TWPing tool. It's a latency task, a latency test, and the destination is this host in the BASnet network. And again, all the parameters, all the switches that you can use, or most of the switches that you can use with TWPing, you can give it to pScheduler that will pass them along to TWPing. So I'm now going to switch to my terminal, and I will show you 3 kinds of measurements. I will first do a measurement between 2 perfSONAR hosts that are running the same TWAMP implementation that we're presenting today. Then I will run some measurements between a perfSONAR host and a JUNIPER router on which we have configured a TWAMP server and reflector. And finally, I will be showing you a third-party TWAMP client and how our TWAMP server implementation is implementing the defined and the standardized protocol, and so working fine with other TWAMP client that can exist. So I will switch to my terminal now. Here. And so the first command I will run is this one.
So Antoine, we're seeing a white screen right now. We may need to check that again.
Let me try again. Can you see it now?
Still looks white to me. Yeah, so other people are confirming solid white screen.
I have selected the terminal window though, so I'm not sure. What can I do?
So instead of sharing the application, maybe just share the desktop.
Yeah, I can try to do that, yeah. Can you see that?
Yes, now we can.
Okay, all right.
And before you go on, somebody had another question here. Andy wants to know, only forward one-way latency reported via pScheduler. So if we wanted a perfSONAR node to test to, say, a JUNIPER router, would we only get data on the one-way latency, or is there a way to see each direction in the perfSONAR tools?
Yeah, I will explain that while doing the demo, because you will see that, and it will make more sense to the other participants that didn't run this command yet, maybe.
Okay.
So the command that I have here ready to run is a TWPing command, sending a flow of 250 packets with an interval of 0.05 seconds, so 20 packets per second, to this other perfSONAR host in the BASnet network. TWPing tells me it needs some time to run that, and it's establishing the session now and starting to send the 250 packets to the other hosts. And we have this output, which shows us the first and last packet sent. It gives us the number of lost packets. Here we don't have duplicates and reflect duplicates. It gives us indication of the round trip time measurements, so the two-way, and the send time and the reflect time. So the send time is the way forward, the reflect time coming back from the reflector. And we have an indication as well of the reflector processing time, thanks to the two different timestamps that Szymon explained to you about. And we also have some indication of the jitter of the different packets between themselves. And also an indication of the number of hops that the TWAMP packet have crossed, or the number of devices they found on the network path, both for the sending direction and the reflecting direction.
So Antoine, somebody would like to know, what is a reflected duplicate?
That's a good question. So let's first start by saying that both Szymon and I are not TWAMP experts, but we just part of the perfSONAR project and implementing the TWAMP protocol. But the way I understand this is that the send duplicates are the duplicated packet seen at the receiver side, and so sent by the sender, and the reflected duplicates are the duplicated packet seen by the sender when it's receiving the flow of packet reflected by the reflector. We can maybe have a closer look at that by using the V switch, which will give us an output containing all the details of each packets that are being sent. Actually, yeah, that's a bit long, but that's fine. So we see that for all, here I have interrupted the process in the middle, but that's not a problem. For all packet being sent, we see the sequence number, we see the forward delay, and we see the backward delay from the reflector to the sender, and the full round trip time delay. We have an indication of the processing delay, and then some indication here. It's a bit too far on the right on my screen, but indication of the error in the measurements because of time missynchronization, probably, or some inaccuracy on the time measurements. And again, even with the verbose output, we have the summary at the end, which actually contains a bug that we will have corrected hopefully next week. So here the summary tells you that those are the statistics from the BASnet host towards the Poznan host, when actually it's the other way around. But it's just a cosmetic bug. It's just in the display that things are wrong here. So we have tested the TWPing command towards another perfSONAR host. I will now run the same or similar command, but towards the another device, which is our JUNIPER router device. And I have here to thank Victor Oliver from JISC, which kindly provided us access to this JUNIPER MX80 router that is running on the lab network somewhere in England. So we see here that our perfSONAR node and the TWPing TWAMP client is establishing the session towards the JUNIPER router and sending the measurements packets. And the JUNIPER router answers back, and we get this statistics. So we have again the way forward delay, the backward delay, and the full round trip time delay that is printed at the end. Now, to come back to the question about pScheduler, let's run those measurements again with the pScheduler tool. So I guess most of you are familiar with pScheduler. This is how you would run a pScheduler latency task with TWPing, as I've shown before. So it's probably, yeah, the screen is a bit too small, so the end of the command line here is cut, but I gave the same number of packets as before, so 250 packets, and a delay of 0.05 seconds between packets. And pScheduler is processing that, is launching TWAMP. And here we have a different output, which is the pScheduler output that is similar actually to the OWAMP output, if you have seen the OWAMP output, OWPing output in the past. So we have the same packet statistics, number of packets sent and received, the lost one, the duplicated one, or the reordered one. We have some statistics on the one-way latency, the minimum, maximum, the mean, the median, some indication of the clock error, some indication of the jitter, and then, like for OWAMP, an histogram of the distribution of packets with the different traveling times that they got. And at the very end, some statistics about the time to live indication in the packets that tells us that we crossed 7 hops on the way towards the destination. And so to answer the questions there from Andy on the chat, so this at the moment pScheduler only gives you access to the forward measurements to the destination. So to the other perfSONAR node that we're running the measurements with. We don't have implemented yet the parsing and the processing of the other informations that are provided by TWAMP in pScheduler at the moment, but this is something that we have on the roadmap and that hopefully we will be able to give you in a future version of perfSONAR. But for now, this is correct that you have only the one-way latency. With pScheduler, I can run some other commands. So I can change here the command I'm running. Maybe it's better seen here on the whiteboard. I will try to make it a bit bigger. So I'm doing a measurements on the reverse way. So I'm asking the other perfSONAR node to be the source and my perfSONAR node to be the destination. And I can do that thanks to pScheduler. So this is the same way you would do it with OWAMP and OWPing as well. And here I had used the default settings for the number of packets, and it's actually 100 packets that are being sent. And finally, with pScheduler as well, I can run this command now using our JUNIPER device as a destination. So I don't need, even though I'm running the latency measurements with TWPing, I don't need to have pScheduler running on the other side, because this is what we call a pScheduler one participant only test. And so pScheduler doesn't negotiate or try to establish a session with the pScheduler on the other side, like it would be for some other perfSONAR measurements that we have, the throughput measurements, for example. So if, for example, I would try to do this, this will not work, but we can try it anyway. So if I try to do the pScheduler reverse measurement, so asking the JUNIPER device to be the source, and this is a way to prove you that on the other side, it's not just a perfSONAR host that is running, but it is indeed a different device. pScheduler here is outputting an error because it cannot find the pScheduler server on the other side, and so cannot establish the pScheduler session and the reverse measurement. Right. So that was about the two different demo with the TWPing CLI command and the usage of pScheduler with the TWPing tool. And now I want to show you another TWAMP client that maybe you know or maybe you discover now. This is an implementation of a TWAMP only client that is running on different OS. Here I have the one for macOS. It has just this simple interface where you give the TWAMP client the destination node that you want to have. So I will take my perfSONAR node there as a destination. I'm using the regular 862 TWAMP control port. I will send, let's increase this a bit. So I will send 100 packets. I will keep the default 50 milliseconds interval between packets and the default 64 byte payload. And I can just start the measurement session. And here we have a nice graphical output of a TWAMP session running between my computer, here my desktop computer, and the TWAMP reflector server and reflector that is running on the perfSONAR node in Poznan. And we have, a nice visualization graph here and details again of packet loss, average latency, minimum and maximum latency, and standard deviation, and the full list of all packets that are being sent along with the control messages. So this TWAMP client shows us that a different implementation of the TWAMP protocol is running fine with our TWAMP implementation. And we can also try to run this same TWAMP client against our JUNIPER router to see if all is well there. Let's see how it's, but no, in fact here it's not working. And this was to be expected because there is an ACL defined on the JUNIPER router, and not everyone is allowed to make the measurements. So this proves you that I'm running this TWAMP session from my desktop computer and not the perfSONAR node on the other side. So that gives me a good opportunity to continue and with a few slides. So I will switch back to my presentation. To show you what the, can you see that? Okay.
Yes, it's
good.
working.
So this is just a snippet of a JUNIPER configuration that shows you how simple it is to enable the TWAMP server and reflector on a JUNIPER device. So you just declare a TWAMP server block. You decide on the control port. You can run TWAMP. So TWAMP is like OWAMP, we said. So it also has an authentication mode if you want to secure your TWAMP session. Here it is disabled. And then we have a client list. And this is where you define which TWAMP client can do measurements towards your TWAMP server. Okay. So let's continue and see what else we can do with TWAMP and perfSONAR. So TWAMP, as TWAMP is available in pScheduler, we also included it as a tool in pSconfig, or actually as it is existing in pScheduler, it comes for free in pSconfig. So that means that you can build a measurement mesh running the TWAMP protocol and TWAMP measurement with pSconfig. And I will show you how you can do that. So in a pSconfig template, you define the kind of test that you want to run. And here we will define a TWAMP test. This is a latency type of test as per the pScheduler nomenclature. And the specification of the test needs to have at least a source address and a destination address. like most of the pScheduler perfSONAR tests that you find in pSconfig templates. And then you can add additional parameters which will refine and the TWAMP session and specialize the TWAMP sessions that you want to run. So you define this block in your pSconfig for the test, and then you use this test in a task block. And here I call this task a TWAMP measurements. I'm using a TWAMP group, which is a special group that I have defined elsewhere in my pSconfig template. To this group, I apply the TWAMP test, and I tell pSconfig the schedule that I run to use for this this run of measurements. And the important bit here is that I have to specify with which tool I want to run TWPing. So which tool I want to run the latency measurements, the latency test, and this is with TWPing. So this should be really straightforward if you know now about the pSconfig template that is existing in the last major version of perfSONAR since 4.1. So I can show you how it looks now on the when you're actually running a measurement mesh like that. So we have, I will switch here to this this other screen. So this is an example of a Mad Dash dashboard running the TWAMP measurements that I just shown you. Here between 7 different hosts, and I will not click on one of, well, you can see here the packet loss and that is reported by Mad Dash. And if you click on one of those square, you will have a graph like this popping up. And the interesting bit here that you can see is that the graphs are showing the latency measurements and are showing that these have been running with TWPing. And if you have different tools running or different latency measurements running on your mesh and with your host, this will get displayed here as well. Right. We'll go back to my presentation. Yeah, this is just what I just shown you, and just a few more words on what we expect to work on in the coming months to further integrate TWAMP into perfSONAR. So there are different possibilities of work area to improve this integration of TWAMP in perfSONAR. As we have seen at the moment, pScheduler is only reporting the forward delay, the one-way delay, and not the other way. So a logical addition to pScheduler output would be to return as well the backward measurements and also the round trip time measurements, so that with a single measurement session of TWAMP, we can have both the forward delay, the backward delay, and the round trip time delay. We have also some interest and feature request to support the jitter data that is given by TWAMP and have it as a reported metric by pScheduler as well. And something that we would like to be working on as too is the support of background streaming measurements. So as you know, in perfSONAR, when you schedule or when you run a latency measurements with OWAMP, the most common way of running it is to start different post-stream sessions that are continuously sending OWAMP packets towards the destination and reporting on the measurements in a continuous fashion. At the moment, we don't have that for TWAMP, but we're looking at the possibility of adding that in the future. And with the perfSONAR toolkit, we would also like to improve the integration and being able to give you the possibility to configure TWAMP measurements through the toolkit web GUI, something that is not possible at the moment. You have to run TWPing either from the CLI or configure it in a measurement mesh. And also being able to choose when you configure a round trip measurements in the perfSONAR toolkit. The only tool available there at the moment is ping, but it would be nice to be able to choose TWPing instead of ping, and at that time we would have a very good support of TWAMP inside perfSONAR. So these are the things that we're looking at in a future version of perfSONAR. And to close this talk, I will just mention here some additional resources that I invite you to look at. So TWPing is a very complete manual page that contains all the information about the different switches and options that you can use. The regular perfSONAR documentation and perfSONAR websites contains also documentation about TWAMP. And this talk that Jason is recording, hopefully we will publish it on our YouTube channel in the future. That where I invite all of you to subscribe if you haven't already done so. And this ends our presentation. And if we have more time for questions, we're happy to answer any of those. Yeah, so I see the question about the list of vendors that should support a TWAMP. Yeah, we don't have a full comprehensive list, so probably the main vendor do support it. But for the other ones, you have to ask your suppliers. Is there some other questions that I missed? Right. And yeah, maybe something else to close this talk, or to leave you with some food for thought for the weekend about TWAMP and the TWAMP implementation. While preparing this presentation with Szymon, we run sample commands and a few of them, and we actually witnessed a TWAMP behavior that we cannot explain at the moment. So if any of you here are interested in digging into that, I can show you something special. Well, this is actually this comment. Yeah, I will change my screen sharing again. So here on my perfSONAR host, I will run this command, this twping client command towards the other perfSONAR host. And I'm now asking to send 10,000 packets, but with one packet every millisecond. And we don't know why, but it seems that twping is not sending all those packets. So if someone has an explanation here on this behavior, we would be interesting to hear. It might be that there is a bug in twping implementation that we need to correct. But we'd be happy to look in more details in that. So I'm asking twping to send 10,000 packets, but only 505 are being sent. And no packets are lost, and there is no duplicates. And this seems to be repeatable. So if I run this command again between the same host, I will get again the same number of packets being sent. Well, so yeah, I see. So can it be added to perfSONAR outside release cycle? I'm not sure what the question is about, but the TWAMP tools, twping, and the integration with pScheduler is available right now at the moment with perfSONAR. So if you're running the latest version of perfSONAR, you have it on your perfSONAR node. So the spec of the host, so it's a 1 gigabit per second NIC host, and it's a 4-core processor. It has 8 gigabyte of RAM. So this is a bit surprising. So when you run OWAMP with the same parameter, this is clearly not happening. So this shows that we have something to look at probably with twping. So OWPing here clearly reports that all the 10,000 packets are sent. And when using the JUNIPER host as a target for these measurements with 1 packet every millisecond, we have, again, a different behavior, but again, a limitation. So this is the puzzle of the weekend.
All right. Does anybody have any other questions? All right. If not, I think we'll thank our presenters again, and I'll make sure that we get this posted to the web. And everybody have a good weekend.
Thank you. Have a good weekend too.